Okay. Hello. Hi, everyone. I'm Chris Owen. I'm from Imagination Technologies, and I lead our team developing our SDK. Oh, what happened there? So today, oh dear, it's a bit problematic. I don't know what I'm doing wrong there. Let's stand back here. I'm going to be showing you our IDE, which is called Catapult Studio, working with an FPGA containing our latest CPU hardware IP. It's called the RTXM-2200. So first, a quick word about the hardware itself. So Imagination, fairly new to RISC-V, but we're investing very heavily. We've built up a really good team of hardware engineers and, of course, verification people, most importantly. So this is our first core. It's a 32-bit embedded core, 11-stage dual-issue pipeline, floating point support. So this is built on a new, clean code base from which we're going to bring that forward and bring out a whole series of cores sold as IP, covering a whole load of market segments. Over the next few years, you're going to see a range of cores in this Catapult range from Imagination. And we think this first one, it's a relatively modest core. We think we've achieved a really good performance density. We think, don't be fooled by the big fan on the FPGA there. This is actually a low power, very performant core. But that's enough about the hardware. So this is about the SDK. So we're making this freely available. You can download it from our developer portal on our website there. It comes, you can run it on your favorite platform, whether that's Debian-based Ubuntu or an RPM-based Ubuntu or Windows or macOS. So you get a curated package of tool chains, C libraries, debugging tools, most importantly, comprehensive documentation and examples. So, we believe that the developer experience is absolutely key to uptake of RISC-V, and we're trying to make that as easy as possible, really. And explaining how to do everything is a key part of that, as well as actually providing the tools. So it gives you all you need to build and debug in C and C++ on a range of platforms, not only our own one, but we want to support as many as we can, and of course that platform support is configurable. And it includes this Catapult Studio IDE, which I'm going to show you today, working with our hardware. So it's based on Visual Studio Code. We've actually decided to fork Visual Studio Code to make our own IDE from the open source code base from Microsoft, rather than just doing an extension. And that allows us to do some more powerful things and integrate it really nicely and closely with the rest of the SDK. So let's show you what it looks like. So you'll recognize this if you've used Visual Studio Code before. Of course, you've got all those nice functionality there. Maybe I'll try and make it a bit bigger. A bit more visible. You've got all the nice features for C, C++ development. So not only you've got the syntax highlighting, but you've got the IntelliSense, as they call it. So I can hover over functions. I can control-click to find the definition of a function and so on. All that stuff is what you normally find. But what we've done is enhance it specifically for embedded debug. And in particular, it understands remote platforms, which is not something that VS Code is good on out of the box. So in this embedded case where you're developing for a platform that's not the one that you're running the IDE on, we've got a platform. If you look down in the bottom right there, we've got a platform selection menu with some popular platforms. But in addition, there's a configuration of platforms UI, so you can set up all the details. So it understands how to connect to a remote target, whether that be in JTAG, OpenOCD, and so on, or indeed model targets are supported. but it also understands things like the memory map of the platform, the CSRs, and so on. The other thing to point out first of all actually is documentation. So as I mentioned, we're trying to make that really comprehensive. So this will tell you not only about how to use all the IDE features and so on, but also how, the compiler flags and details of options in the compilers and so on. Worth mentioning actually, we do have a compiler team. So we are working particularly on LLVM with the rest of the LLVM community and contributing to that, and also of course optimizing it for our own hardware, making sure that we can squeeze as much performance as we can out of our own hardware. So as I said, it knows how to connect to a target. I can just here press the go button. So this is now connecting to the core and the FPGA there. It's running OpenOCD to connect via JTAG, and then running GDB, starting a session and ending you up on a breakpoint there. And you can, of course, do the usual things, stepping through, setting breakpoints, and so on. What I've got here, this program, as you can see, is just a bit of an enhanced hello world, because I'm creating some vectors of data that I can visualize and so on. So I've copied a string in there and so on. So I can show you a few of the embedded debugging features that we've put in this embedded debug menu here. So for example, we've got a memory window that we're quite proud of. So for example, I put in here that str that I copied that string into, so you can see that you've got the it's interpreted as the ASCII there. Let me just close this bit down a bit more, see what's going on. So it's also color-coded it, so it understands the memory map of the platform, and it's color-coded the different types of memory in different colors. I can view the thing with different word widths and so on, but I can also, I've got this data inspector, so I can go and, actually I've managed to lose my str there. So I can interpret it in different ways, as signed, unsigned, float, and so on. And of course it's editable, so I can go in and start fiddling with this, and the changes will come up red. So it's quite a full-featured memory window. We've got other embedded debug windows. There's a peripheral register window. So this is arranged in a kind of hierarchy. So you've got devices at the top level, and then registers within devices, and then bit fields within registers. And I can start editing these and playing around with my peripheral registers. And one thing I've also got is a vector plotting window. So this is for visualization of data. So this might be useful, for example, if I'm just going to run on to this next breakpoint. So I've just copied a sine and cos wave in a couple of arrays there, just to visualize something. So this might be something that you'd use if you were doing DSP or something like that, and you actually got data that represents real-world data. So again, I can enter in cos wave here to view that and so on, and then I could view the sine wave on the same plot. Oops. And so on. So, and then, I've got lots of features in here. I can hover over things to get their values. I can zoom in on different bits of it, and so on. I can add additional plots and make it full screen, all the rest of it. So again, quite full-featured. And this is fairly early days. We're going to add to all this and add to our debugging features. Worth noting as well, one thing I forgot, of course, that on the subject of understanding the platform, it knows all about the registers. So actually, let's just close some of these others down. And if I expand that. You've got all the CSRs and so on in the platform, including custom CSRs, and you can look at all the registers in your target. So, as I say, we're hoping that this is helpful to help developers on a lot of different platforms, really. As I say, download it from our website, give it a go, give us some feedback. That would be great. and we're going to take it forward and put lots more features in it as we go on. I think I'm out of time, probably. Yeah, that's about it for my time. So thanks very much.